Continue now. So looking at part B. So part B tells us that we have x is equal to e to the minus t, and we are dividing that by the square root of 1 minus t squared. So that is x, all right? And they tell us that, of course, y is equal to sine inverse of t. Y is sine inverse of t. Sine inverse of t. All right, and they tell us that this information is critical as well. They tell us that t is between -1.5. And I didn't put this right, it's strictly -1. Good, now they ask us to find dy by dx, or rather prove that dy by dx is equal to that. All right, so let's go ahead and do that. So to find dy by dx, we have to remember that dy by dx is equal to, dy by dx is going to be equal to dy by dt times dt dx. So come let us find dy by dt first. dy by dt is going to be equal to 1 over the square root of 1 minus t squared. That's dy by dt. Good. Now we need to find dx dt. Dx dt is going to be equal to, first thing is you start with the bottom. You're going to have to use quotient rule to differentiate this. All right, dx dt, let's do it in different colors. You start with the bottom, 1 minus t squared, square rooted. You multiply it by the differential of the top. The derivative of the top is minus e to the minus t. Minus the top. The top is e to the minus t. So minus the top times the derivative of the bottom. When you differentiate this bottom now, you carry down the power, because this is really 1 minus t squared to the half. Minus, you carry down the power half. You subtract 1 from the power to get 1 minus t squared to the minus half. Then you multiply it by the differential inside the bracket, and the derivative of t squared is 2t, so that's multiplied by minus 2t. Then it is divided by, of course, the bottom square. The bottom square is just going to be 1 minus t squared. So that's dx dt. Let us simplify it by prettying it up. So dx dt, by prettying this up, will be minus e to the minus t times the square root of 1 minus t squared minus, now this part now, anything to the minus half, we can put that in like a denominator. All right, so this, we're gonna have in the denominator the square root of 1 minus t squared. In the numerator, we're gonna have a 2 here, but this 2 cancels this 2. This minus and this minus makes this become a plus. All right, and then the e to the minus t goes in the numerator. That's how you simplify this part, because this 2 cancels this 2. All right, so this 2 cancels this 2. Minus and minus make it become plus. And then we have a t right here as well. So it's t times e to the minus t. And all of this is being divided by 1 minus t squared. All right, nice and easy. So that is dx dt. That is dx dt. All right. So this is dx dt. We can continue now. We can simplify this some more. I always advise to simplify it. So dx dt is going to be equal to, we can simplify the numerator as one fraction. As one fraction, we can multiply 1 minus t squared. The 1 minus t squared times 1 minus t squared, that will just give. The square root cancel each other, so this part just works out to be 1 minus t squared. Plus, we have plus t times e to the minus t. Plus t times e to the minus t. All of that is being divided by the square root of 1 minus t squared. And remember, it was divided by also 1 minus t squared, so it becomes the square root of 1 minus t squared times 1 minus t squared. So this is dx dt. All right, nice and easy. So let's just separate them, separate the space. So that's dx dt. Now remember, what we want is dy by dx. So let's get back to what we really want. So dy by dx, we know that dy by dx is of course equal to dy by dt. So it's dy by dt times dt dx. Now you may ask, but sir, we don't have dt dx. Yes, we do. We have dx dt, and so dt dx is just the reciprocal of this. And so dy by dt is going to be equal to dy by dx, which we found to be 1 over the square root of 1 minus t squared multiplied by dt dx. Now dt dx is going to be the square root of 1 minus t squared multiplied by 1 minus t squared. And all of this is divided by this part now in the numerator. So it's now minus e to the minus t. Now look what I'm going to do, guys, just to make it be easier. I am going to factor out. All right, let me do that in the next line. I was going to factor out, so I'm just going to write it. Minus e to the minus t times 1 minus t squared plus t times e to the minus t. Now, as you can clearly see, this square root of 1 minus t squared cancel the square root of 1 minus t squared. And so what we're getting is just, in the numerator, it becomes 1 minus t squared. So in the numerator, it works out to be equal to 1 minus t squared over, now in this denominator, I'm going to factor out e to the minus t. Let's factor out e to the minus t. If we factor out e to the minus t, right, what we're left back with is factoring out e to the minus t. That will become, this will become t squared. And you're wondering where t squared come from? T squared minus 1. That part becomes t squared minus 1 plus 1 plus t. All right, t squared minus 1 plus t. And you're going to be like, where that come from? Right here, I factored out e to the minus t. Factoring out e to the minus t, I'm going to have minus 1 minus t squared. But minus 1 is minus 1. Minus minus t squared is positive t squared. And factoring out e to the minus t, leave from here, just leave plus t. So this is what we have. Now, one quick bit of information is, look at this. E to the minus t, the denominator. If you have 1 over e to the minus t, 1 over e to the minus t is just 1 divided by e to the minus t is 1 over e to the t. So this is what we're having now. 1 over e to the minus t is 1 divided by 1 over e to the t. 1 divided by 1 over e to the t is e to the t. So what am I saying? I am saying we can put e to the t in the numerator. Put it in the numerator, so 1 over e to the minus t becomes e to the t times 1 minus t squared over, in the denominator you have, that's t squared plus t minus 1. T squared plus t minus 1. And positive, that's what they had. Yes, that's what they had. And so we've proven it. That is dy by dx. Nice and easy. Soft. So proven. This is dy by dx. All right. Nice. Soft. Now it says, hence, show that f has no stationary value. Now this is a unit 1 concept. What do we know about stationary value? At a stationary point, dy by dx equals 0. At start point, we know that dy by dx is equal to 0. So let's show that at this stationary point, dy by dx is 0. So first we need to find the stationary point by solving dy by dx equals 0. So we just found that dy by dx is e to the t times 1 minus t squared. So it's e to the t times 1 minus t squared over t squared plus t squared plus t minus 1. All right, and we're setting that equal to 0. If this is equal to 0, anytime something is 0, it must be the numerator be 0. So we're really solving e to the t equal to 0, which is e to the t times 1 minus t squared equals 0. Now, e to the t can't equal 0, right? E to the t can never equal 0. So that's really telling us that we're solving 1 minus t squared is equal to 0. So if we're solving 1 minus t squared equals 0, then that is telling us that t is equal to -1 or t is equal to 1. T is equal to -1 or t is equal to 1 at the stationary point. But remember from the question, it said that t is between, it said from the question t is between -1, t is between -1 and a half. T is between -1 and a half. Now, none of these values are between -1 and a half. All right. So the function is only defined between these values. So the stationary point, which is this one, which is bigger than a half, and this -1, which is not included, it's not inside the function. So hence, it has no stationary point. Hence, it has no stationary value. All right. Nice and easy, soft, and that takes care of question 1. Nice. Now let's go to question 2.